Hi students, in this video I'll be going through the 2022 O-Level Additional Mathematics Paper 2 Question 3. Alright, so let's read the question. So in part A of the question, they want us to prove the identity tangent 2 theta times 2 cosine theta minus secant theta equals to 2 sine theta. Alright, so this is a question regarding the proving of trigo identities. So for the proving of trigo identities, we always want to start from the side that is more complicated, right? So it's quite obvious that for this particular identity, the left side is more complicated. Okay, so we are going to start proving from the left side, right? Okay, so left hand side is equals to tangent 2 theta times 2 cosine theta minus secant theta. Okay, so at this point in time, we often, for the proving of trigo identities, we need to look at the other side, the right side, and see what do they want us to prove. And you can see that they want us to prove just 2 sine theta, okay? So this is a single angle, okay? So a single angle. Okay, then on the left-hand side, where we are going to start, you can see that there's a tangent 2 theta. Okay, so this means that likelihood we'll need to apply the double angle formula to convert tangent 2 theta to a single angle. Okay, but if you recall the double angle formula for tangent is this, tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. Okay, so you can consider that if we were to replace tangent 2 theta with the equation for its double angle formula, 2 tangent theta over 1 minus tangent square theta, it's going to actually make the expression rather complicated. Okay, and if you think about it, later on if you want to open the brackets, it's not really going to help us to simplify anything. Alright, so because when you open the bracket, you're going to multiply by 2 cosine theta and then secant theta. So it's not going to really help with anything. Okay, so this is probably an approach that we do not want to take because it seems quite obvious that we can't really simplify anything. Okay, so one of the things that we should always consider when we want to simplify trigo identity is that you always try to convert everything to in terms of sine and cosine, and then we will work from there, and hopefully we'll be able to cancel off some terms, all right? Okay, so over here, you see there's a tangent 2 theta, and you should recall that tangent is actually sine over cosine, right? Okay, so one of the things that we can consider will be to convert tangent 2 theta to sine 2 theta over cosine 2 theta. Right, so let's try that. Okay, so tangent 2 theta is sine 2 theta over cosine 2 theta. Okay, then over here, we have a 2 cosine theta. And then we should think about, okay, secant theta. Can we convert it also to in terms of sine theta or cosine theta? Right, so you should be quite familiar that secant theta, we can actually write it as 1 over cosine theta, right? We can write as 1 over cosine theta. Okay, so at this point, remember we need to get a single angle on the right side. So now we can consider to use the double angle formula for sine 2 theta. Okay, so sine 2 theta is 2 sine theta cosine theta. Okay, if you recall cosine 2 theta, there are actually 3 forms of the double angle formula. Okay, so cosine 2 theta, we actually have cosine square theta minus sine square theta. Okay, the first form, or we have 2 cosine square theta minus 1, or the third form we have 1 minus the 2 sine square theta. Okay, so which form we are going to use, we are still not so sure. Okay, but let's see later on in the question whether we can come to a consensus of which one to use now. So for now, I'll just leave it as cosine 2 theta. Okay, then if you look inside the bracket, okay, ask yourself this question, what else is there to be done? Okay, with 2 cosine theta minus 1 over cosine theta. Okay, so one of the things when you have two terms will be to combine them together as a single fraction, right? So maybe that will be something that we want to do. Okay, so let's try to combine this as a single fraction. Okay, so 2 cosine theta, the denominator on the second term is cosine theta, right? So we want to introduce the same denominator, and then we will be able to combine them together. Okay, so we would add a cosine theta at the top and the bottom. Okay, so 2 cosine theta will be 2 cosine square theta over cosine theta minus 1 over cosine theta. Okay, then let's combine. Okay, inside the bracket. Okay, so we will have 2 cosine square theta minus 1 over cosine theta. Okay, if you look at the double angle formula, 2 cosine square theta minus 1 is actually cosine 2 theta, right? Correct? So now we can replace this 2 cosine square theta, okay, as we write it as cosine 2 theta, and you will be able to cancel off with the cosine 2 theta over here, right? So let's do it. Okay, so basically what we have now is this. Okay, so now this one, we can use the double angle formula in reverse. Or if you want to change this cosine 2 theta to 2 cosine square theta minus 1 and cancel off, it's the same thing, right? So I'll change it to 2 cosine theta over cosine theta, right? And then we will cancel off and we will be left with, okay, 2 sine theta cosine theta. Okay, we cancel off this one. Okay, these two terms, 1 and 1. Okay, then we'll be left with 1 over cosine theta inside. Okay, so 2 sine theta cosine theta times 1 over cosine theta. And now the cosine theta will cancel off, and then we will be left with the 2 sine theta, right, that they want us to show. Okay, so just like this, we have shown the right hand side. Okay, so this is how you simplify trigo identities. Okay, you need to pause first, think, look at the right side. What do they want us to show? And then you slowly work from there. Okay, make the correct decision. Right, so in this case, the decision will be not to replace tangent 2 theta with its double angle formula, because that will not be able to simplify things. Okay, so remember, one approach is to always change everything to in terms of sine, cosine, and then see whether you can simplify from there or not, right? Okay, now let's look at part B of the question. So part B, we have tangent 2 theta. They want to solve the equation. Tangent 2 theta times 2 cosine theta minus secant theta is half secant theta. Okay, so you should realize that this left side of the equation is what we have proven previously. Okay, so we have shown that this thing is actually equals to sine 2 theta. So the question says hence, that means they want us to make use of what we have obtained in the first part of the question to help us to solve the second part of the question. Okay, so indeed we are going to replace this tangent 2 theta times 2 cosine theta minus secant theta with what we have shown in part A. Okay, so now the equation will actually simplify to just this. Okay. Okay, so now this is the equation that we want to solve. Okay, so 2 sine theta equals to half secant theta. Okay, so remember, every time you want to solve a trigo equation, we always want to try to obtain just a single trigo function. Okay, either sine, cosine, or tangent, and then we solve from there. Okay, so now the left side, there's nothing much that we can do to change anything. Okay, but the right side, okay, if you recall, secant is again 1 over cosine theta. Okay, now we can multiply the cosine theta upwards, or multiply both sides by cosine theta. Okay, so we'll be left with 2 sine theta cosine theta equals to half. Okay, so basically from here to here, we are multiplying by cosine theta throughout. Okay, and you should realize, okay, have the awareness that 2 sine theta cosine theta is actually sine 2 theta, okay, equals to half. So this is the objective that you want to arrive at, okay, for all trigo equations. To just have one single type of trigo function equal to a particular fraction or number, right? Okay, so from here, all we need to do is to just solve it, find the basic angle, and search the relevant quadrants to find all the angles, and we should be able to solve for theta already. Okay, so now we're going to let sine alpha equals to half. Okay, so where alpha is the basic angle. Okay, so sine alpha equals to half, so sine inverse of half. Okay, so sine half is a special fraction, right? Okay, so the basic angle would be actually 30 degrees. Okay, sine 30 will give us half. So basic angle is sine 30. Okay, so over here we are solving for 2 theta. Okay, so we got to adjust the range. Okay, so times 2 to the range, so 0 to 300, 720 degrees. Okay, meaning we are actually going to search 2 rounds. Okay, 720 degrees is 2 full rounds. Okay, so psi is now positive. Okay, so we will be searching in the first and second quadrants. Okay, where psi is positive. Okay, so search in the first and second quadrants. Okay, so the first angle for 2 theta will of course be 30 degrees. Okay, the angle in the first quadrant. So in the second quadrant, basic angle is 30. So the angle will be 180 minus 30. Okay, then now we're going to go to the second round already. Okay, so to find the angle in second round is very easy. Just add 360 to both of the angles that we have found in the first quadrant. So 360 plus 30, and then 360 plus 180 minus 30. Okay, so this will allow us to find all the angles in the first and second quadrants that we need. All right. Okay, for 2 rounds. Okay, then let's simplify this first. We get 30, 150, 390, and then 360 plus 150, so you get 510. Okay, then one final step. Remember what they want us to solve is for theta. So you get 15, 75, 390 divided by 2, 195, and then 510 divided by 2, 255. Okay, so this will be the 4 answers. And the 4 answers should all be within this original range of 0 to 360. Right? Okay, so this is how you solve a question like this, making use of answer from part 1. Right?